Okay, third problem. We have a function that gives us the weight as a function of height, where the weight equals x, x being your sea level weight, equals 4,000 over 4,000 plus h quantity squared, h being height in miles above sea level. So, what's weight at 10,000 feet? Okay, let's try to get the focus back. Okay, now at 10,000 feet, first of all, let's assume sea level, weight, 170 pounds. Okay, then the height in miles, well, the height's given in feet, so x is sea level weight. We're going to assume 170 pounds. You can use your own weight, you can use your own ideal weight, you can use any weight you like here, any reasonable weight, any reasonable human weight. I don't care what you weigh, I don't care what your ideal weight ought to be. I hope you like your weight, but that's about it. Okay, so h equals what? It's 10,000 feet divided by 5,280 feet per mile, and that equals approximately, let's see, that's about 6% less than 2 miles, so that would be about 1.88 miles, okay? And you can check that out. You can do that division and see what you think and see if I did that right. And if you catch me in a mistake, very good. Okay, so now we can go ahead and plug that in here. So the weight equals 170 pounds times 4,000 over 4,000 plus 1.88 quantity squared. Now, that's about 2, so that's about, I'm just doing this in my head, you don't even have to listen. But my strategy is, that's about 2 miles, which is about 1/2000th of 4,000. So we're off by a factor of 1 out of 2,000. When we square it, we're going to be off by a factor, it turns out, of about 1/1000th. And the denominator being bigger than the numerator, this fraction is going to be less than 1, so we're going to have less than 170 pounds. And I say that comes out 169 point, so subtracting 17. Be careful. It's going to be 0.17 less. Yeah, so that comes out 0.83 pounds, I think. Now, I used a method that you won't be aware of in doing that, but just using a couple of simple rules of thumb, I come out with this, and I hope that's right. You can double check it by actually punching this into a calculator. That's certainly a reasonable thing to use a calculator for. Okay, so that's our weight at 10,000 feet. The weight at 20,000 feet, well, we just do the same thing, and I think we get approximately 0.68 off of that would be 3.2, so I think we get 169.3, wait a minute, 68, yeah, 3.2 pounds. These won't be exact. If you do this exactly, you might find that we're off by 100th or so. You might find that I did something completely boneheaded, and I'm off by much more than 100th. But this is how we would get the results. You do the arithmetic and check and make sure that my approximations are okay. Now, there's a further implication of this problem. By how much did each differ from your weight at sea level? Well, this differs 170 pounds by negative 0.17 pounds. And this differs from 170 pounds by negative 0.68 pounds. If you want to show off, you can see that this is 4 times this. And if I did this wrong, this result is still going to be 4 times this result. And that goes along with proportionality and variation that we could talk about but won't. But the one thing I will expand this into is a discussion of rates. The rate implications of these results. And I'm going to do that in a separate video, so you can ignore it if you like. But rates are also important in this course, and this will give you a little more insight into rates, and it'll be a fairly short segment, fairly short calculation.